So for this unit, we are dealing with exponential rules or exponents and scientific notations. This is kind of a long unit. So usually once we get to this unit here, that's when things start to go downhill for a lot of students, because this is when it gets more challenging. Lots of students have trouble with these remaining units, but honestly, you will see a lot of this stuff again in Algebra 1. You will see solving equations again. You will see systems of equations, multi-step equations, 1- and 2-step equations, functions, which is basically just graphing. So you will see all of this stuff again, except scientific notation. You probably won't see that again in Algebra 1. But you will see this stuff again. So right now it's kind of good to kind of just learn it, practice it. But you will see it again if you're not able to master it just yet. So the unit first goes over square roots, cubed roots, right? Square root of 4. What number times itself twice gets you 4? 2. Cubed root. What number times itself 3 times gets you 27? 3. Equations with square roots and cube roots, roots of decimals and fractions, etc. Multiplying exponents, dividing, raising to a power. Dealing with negative exponents, multiplying and dividing with negative exponents, then gets you into scientific notation and powers of 10, multiplying and dividing with scientific notation, adding and subtracting, word problems, and that's the entire unit. So let's just do the unit test. It is 14 questions. So it says, rewrite this in exponential form. Well, you have a times a, so how many a's are there? 1, 2, 3, 4, 5, 6. So you have a to the 6th power, basically, if you were to write that in exponential form, over a to the 1st. Rules of exponents. So look at the rules that I gave you. When dividing exponents, you subtract. So 6 minus 1 gets you 5. This can be rewritten as a to the 5th. Or you could just cross them out. Just cross out one of them. How much do you have left? a to the 5th, whatever you prefer. Okay, so for this, you can use a calculator. What's the square root of 1.96? Well, let me use my calculator. 1.4. So basically 1.4 times 1.4 gets you 1.96. Find the solution. B squared equals 120. Okay, so basically what times what gets you 16? 4 times 4. What times what gets you 121? 11 times 121. So basically 4 squared over 11 squared gets you that answer. You would just take the square root of both. So none of these is going to get you, actually here it would be 4/11. Even if you did a negative, let's see. Yeah, 2 negatives would give you a positive, so that would work as well. Both of those would work. Same thing here. What would get you 49? Well, 7 squared and negative 7 squared. Also, the square root of 49 is 7. The square root of negative, okay, this would all of them would work. Harvey Porter is a wizard. He waved his wand and made a grain of sand that had a diameter of 0.00002 grow to a diameter of 0.006. Approximately how many times larger is it? Okay, so we want to divide this, right? We have point, so it grew to 0.006. So 0.006 divided by 0.00002 gets you 300. So it looks like it's 300 times as large. If we were to write this in scientific notation, with scientific notation, you want to put a decimal right after the first number and then multiply it by 10. So if I put a decimal here and multiplied it by 10, it would be to the 2nd power because I would move my decimal over 2 places to get back to 300. Even if you put that in your calculator, 3 times 10 to the 2nd, it would get you 300. Negative exponents go in the other direction. Select the equivalent expression. Well, bases must be the same. So we cannot multiply those together unless the bases were the same, but we can apply that to both of those. Negative set. So this is called raising to a power, or the power rule, when you basically apply the outside exponent to what's in the inside by multiplying it, as you can see there. So I'm going to multiply that 2 by negative 7. That would get me negative 14, and then 5 times 2 is 10. Your answer would be A. Okay, what's the cubed root of 125? Well, your calculator would do this for you. Basically, what number multiplied by itself 3 times gets you 125? And that would be 5 times 5 times 5. Okay, so if we were to raise to a power, that would be 3 times 2, which is 6. The annual expenditure of the U.S. federal government is approximately $4 trillion. If a dollar bill is 0.0001 meters thick, how many meters tall would a stack of $4 trillion be? For reference, 1 trillion is equal 10 to the 12th. So that is a lot of money. Okay. So we're going to multiply. If you have $4 trillion, you would multiply it by this. So if you were to write out 4 trillion, and that's why you do scientific notation, so you don't have to deal with all these numbers. Let me just make sure. $4 trillion. Scientific notation. I just want to make sure I have the correct amount. Okay, I think I've put too many zeros. It would be 4.0 times 10 to the 12th. Oh, well, they did say 1 trillion was 10 to the 12th. I don't know why I misread that. Oops. So it would be written out like this, right? 4 trillion would basically be 4 times 10 to the 12th power. Well, if $4 trillion is 0.001 meters thick, you want to multiply that by this. If I were to write this in scientific notation, that would get me 1 times 10 to the negative 1, 2, 3, 4. So this is what you're basically multiplying here. So 4 times 1 is 4. 10 to the 12 times 10 to the negative 4th. Well, rules of exponents. When multiplying, you add. So 12 plus negative 4 will get you 8. And that's the easier way to do it. You can also, just type in $4 trillion. So I'm putting in my calculator 4 trillion. So that's 12 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If I multiply that by 0.0001, my calculator basically give me a 4 with 1, 2, 3, 4, 5, 6, 7, 8 zeros, which is basically this in standard notation. So this is scientific notation, which they want it. If I were to write it in standard notation, it would look like this. Okay, rewrite the expression. Okay, they have the bases the same. If we multiply them together, rules of exponents, you add. 11 plus negative 8 is 3. Express your answer in scientific notation. Okay, well, let's add those numbers together. So 2.3 times 10 to the 8th plus 4.7 times 10 to the 7th would get me so you can enter this in your calculator and it will do the math for you. Or you can just write it out, right? 1, 2, 3, 4, 5, 6, 7, 8. Plus 1, 2, 3, 4, 5, 6, 7. So if you wrote these in standard notation, it would look like this. Sorry if they don't match up, but if I were to add those in my calculator, I would get 277700000. So right, that's why you do scientific notation, so you don't have to deal with all these zeros. This would basically be 2.77. So if I were to put a decimal right here, that would be 1, 2, 3, 4, 5, 6, 7, 8 spots. So 2.7 times 10 to the 8th is what these would equal if you added them together. They did a different method. They basically made both of these 10 to the 7 because rules of exponents, in order to add things together, the exponent has to be the same, which they did. They just moved it over 1 and they made that 10 to the 7th. They then did 23 plus 4.7, which got them to 27.7 times 10 to the 7th. They moved it over 1, which then got 10 to the 8th. So whichever way you want to do it, you can do it. A cube with a side length of z has a volume of 216. Okay, so what is the side length? Basically, exponents are like kind of the opposite of, z to the third is basically the opposite of the cubed root of z. So basically, what is the cubed root of 216? That's what we're looking for. So you can put that in your calculator. It'll do the math for you. And I got 18 radical 6. A cube with the side length of c has a volume of 216. Do they want us to put it in? That's what I did. Cubed root of 216. Oh, sorry. I don't know what I did the first time. My calculator gave me a weird number. But yes, if you type in the cubed root of 216, you get 6. Okay, next one. 6 to the second power is 36. What is also equivalent to that? Well, if you cancel those out, that 6 times 6 times 6 is not 36. 4 minus 2 is 6 to the second, which is 36. This would get you 9 minus 8, which is 6 to the first, times 2. This one also works because that gets you 36. So A and C. 2 times 2 times 2. Okay, I would put that in my calculator. Basically, this is 2 to the 6th power. 2 to the 6th power is 64. That does not work. This would, if you were to multiply exponents, rules of multiplying, you would add them. And then rules of dividing, you subtract. That one also works. So A, C, and E all are equal to 6 to the second power, which is 36. Those are equivalent expressions. Okay, so this is 1 over y to the 6. What's equivalent to that? Well, rules of exponents. If you have a negative exponent, you would rewrite it with it in the denominator and it would make it positive. So that would be going backwards. That's the answer. And that's pretty much this unit. So since we're getting into more, more of the, we're finishing up pre-algebra, we're getting into more of the more challenging problems, I want you to let me know which problems you have questions on. You can screenshot them, send it to me. Make a list of problems that you don't understand. That way I can make additional videos on questions you need help on. Because like I said, this gets more challenging for a lot of students. So we want to work on what you don't understand. So let me know if you have any questions. Good luck.